In this video, we present PDViz, an interactive visual analytics approach for policy diffusion data. PDViz uses coordinated multiple views to provide different perspectives on policy diffusion spread in the American states to inform policymakers, journalists, academic researchers, and citizens alike. Here is the overview of PDViz: configuration menus, policy diffusion analyst view, geographic view, and policy adoption view. The configuration menu shows the list of options that users can choose to analyze the policy diffusion data. Using this panel, users can choose the analysis type and method, policy topic, time range, and sorting orders. It also presents the color codes used in PDViz. The policy diffusion analysis view allows users to analyze the policy diffusion patterns by state and topic. This view consists of policy diffusion chart and a policy matrix chart. The policy diffusion chart presents two underlying patterns for the selected topic and for a topic or a policy which users mouse over on, up, and down respectively. The state abbreviations and the color-coded glyphs represent the degree of measurements that are aligned. When users make mouse over actions on a state abbreviation or a glyph, paths starting from the state are highlighted in one of blue, red, and purple colors, while those without a connection are dimmed. Each represents the incoming, outgoing, or bidirectional pattern. The policy matrix chart shows the heat map overview. The policy matrix and the policy diffusion charts are vertically well aligned and share the same x-axis. The blue and red color intensifies on each cell across the x and y axis, which represents the relative values of the numbers of new policies and existing policies adopted respectively. They present two different levels of details by following whether the user specifies the topic in PDViz. When the user specifies a topic, the policy matrix view is updated to show how the policies spread. The blue and red circles in each row indicate the candidate states considered to have first created the policy and the states that have since adopted the policy. When users hover the mouse over the policy label in the y-axis, a tooltip appears, and it shows a list of contextual factors along with the associated hazard ratios from a Cox proportional hazard model. It allows users to analyze how much the social factors affect states to adopt or not adopt a policy. The map view shows the United States. This view allows users to analyze the neighboring effects on policy diffusions, as users can easily recognize the geographical proximity using the map. The states are colored by the degree of measurements. It provides two styles of map, the US's actual map as well as a hex bin map. The policy adoption view presents the number of policies showing the adoption trends. It provides 4 tabs: by year, by state, by topic, and by context. The first 3 tabs provide the bar chart showing the number of policies that are newly created or adopted from the other states by year, state, and policy topic. The By Context tab provides a line chart representing social factors and includes small red and blue boxes with state abbreviations written on them. 3 views are coordinated with each other. The mouse interaction in the policy analysis view affects the other views. When the user mouse hovers over a cell in the policy matrix chart, the diffusion path of the upper and lower paths in the policy diffusion chart are highlighted. It allows the users to compare and analyze the diffusion patterns in topic context. Also, the boundary of states in the map view having connections to the mouse hovered state is highlighted. The tabs in the adoption view show the filtered results by state and topic. For example, when users hover the mouse over a state in the policy diffusion chart, the By Year tab shows the adoption records that the state has made. When users hover the mouse over a topic label in the policy matrix chart, the By State tab shows the adoption records that the US states have made for the topic. Similarly, the mouse action in the geographic view also affects the 2 other views.